Welcome to the next video on partial fractional decomposition. When we're given an expression like this, we know that if we can factor the denominator, then we can write it in a form which is in fractions, something like this, which we call our partial fraction decomposition. I know that there have to be 3 of these fractions because the denominator has a power of 3. I'm just going to give you the factorization of it. At the end of the video I'll show you how to factor it if you're not sure, but it becomes, what was it, x minus 2, x plus 1 squared. Now how that converts into the denominators, the x minus 2 is simple, that's just on its own. And the way, I don't have a good way of remembering this, but I figure if they were both x plus 1, there would be no point because they're the same. Same if they were both x plus 1 squared, there would be no point. So it's probably one of each, or it is one of each. So we know it's going to look like that, and now we need to find the numerators. We don't know what they are, so we're just going to call them big A, big B, and big C for now. Big variables that have lots in them. If we get a common denominator, we can get rid of the denominator altogether. So A then would be multiplied by x plus 1 squared. B has to have an x plus 1 and an x minus 2, and C just needs the x minus 2. And now imagine the denominator was under that, but I'm not going to bother writing it because the next thing I'm going to do is get rid of it. We're going to equate this to the original numerator. So because the denominators on both sides are the same, we can drop them. We can equate the numerators. Just to make it clear what I've done there so you don't think I just got rid of it for no good reason. Now we could expand this to figure out what A, B, and C are, but there's an easier way to do it than that. If we take some kind of smart values. For instance, if x is negative 1, you can see that this A term here is going to be 0 because negative 1 plus 1 is 0, and that makes the whole thing 0. Same with the B term here. So that's a good value to do. That's going to be a 1 minus 3 plus 5 is equal to C, and x is minus 1, so that's a minus 3. Minus 2 and 3 equals, well, that's easy. C has to be negative 1. Now we can try, how about x equals positive 2? Similar kind of reasoning. 1 plus 6 plus 20. These two terms are going to be 0. So we just have A, and x plus 1 is 3 squared is 9. Well, so that's easy too. 27 is 9A, so A has to be 3. Now to figure out the B term, it doesn't really matter what we do, so let's use x equals 0 because that seems promising, I think. It means on the left-hand side all we have is a 1, which is nice. We have A, which is 3. Oh, but it's 0, so we'll ignore that. No, it's not. Sorry. Boop. 0 plus 1 is 1, so we have an A. And 0 plus 1, 0 minus 2. We have a minus 2B. And for C, we have minus 2C. But we know A is 3. And we know C is minus 1. So we have that 1. Now let's start moving things now. And that tells us that B is 2. So now we have our fractional decomposition. We could go back and write them in here. A is 3, B is 2, and c is -1. So that's the fractional decomposition. Now, I promised you I would go over the factoring. If you're needing help with this, probably the easiest way to get into it is to do the same kind of thing we just did, looking for the roots of the equation. We have x cubed minus 3x minus